Hello, my dear students. So, in the last lecture, we studied the basic introduction of slope deflection method and what are the fixed end movements for the different loading, if it is point load, if it is UDL, and after that one, what is the sign conventions, and after that one, we studied the what is the basic procedure to solve the slope deflection method. These are all things we discussed in the last lecture. In today's lecture, what we'll do? So, we'll solve a problem on slope deflection method. So, we'll get an idea to how to solve the problem. So this is the problem. Okay, so what it is, so here we are supposed to analyze the two span continuous beam by slope deflection method and draw bending moment and shear force diagram. So if you see this diagram, so this is a two span beam. So here span AB is 4 meter and span BC is 6 meter, and the loading is 40 kilonewton. It is acting exactly the center. So 2 meter is from A, so it is centrally it is loading, so that is center point load, so that is 40 kilonewton, and for BC span 20 kilonewton per meter the loading is acting. Okay, so for this one we are supposed to calculate the what is the movement that is to be developing in span at end MAB, MBA and MBC, MCB. These are the these movements we are supposed to calculate for this problem. So already we are discussed. So what is the step number one? Step number one is to calculate the fixed end moment. So for span AB, the loading is exactly acting at the center. So that's why what is the formula for that one is, for MFAB will be equal to minus WL by 8 and MFBA will be equal to plus WL by 8. So what is the value of W here? W is equal to 40 kilonewton. So 40 into what is the span for W into L? L is 4 meter. So L is 4 meter and divided by 8. So if we will calculate, that is minus 20 kilonewton meter is the answer. Okay, same thing for MBA will be equal to, this is minus 20 means this will be plus 20, because formula only the sign is going to change. So this is the case for span AB. Same thing if you go for the UDL. So what is the formula for UDL? If you remember, if it is UDL, then the formula for that one is minus WL square by 12. So what is the formula? Minus WL square by 12. So for the what is the value of W? What is the intensity of loading for this case? That is 20. 20 is the intensity of the loading. So for that one, 20 into L is span. What is span? It is 6 meter. So 20 into 6 square divided by 12. If you solve, you are getting minus 60 kilonewton meter. Same thing for MBC, it is minus 60 kilonewton per meter, and for MCB, so MBC minus 60, and for MCB that is with plus sign, the plus WL square by 12. So same thing, 20 into 6 square divided by 12, that is plus 60 kilonewton meter is the answer for this one. So this is step number one is over. Now I am supposed to go for step number two. Step number two is what means, you are supposed to use slope deflection equation, and you are substitute the values that is to be calculated in the equation number one. So what is the formula for slope deflection equation? The slope deflection equation says MAB is equal to MFAB plus 2EI by L into the bracket 2 theta A plus theta B minus 3 delta by L. This is the formula. Okay, so for this one, just now I calculated MFAB. So what is the value of MFAB? That is minus 20 to EI by L. Here if you read the question, there is no value is given for EI. So if any value has been given, then you can substitute that value. EI value is not given, that is flexural rigidity. Okay, that's why you put as it is. So EI as it 2 EI divided by L. L means what? L means the span of AB. Span of AB. I am taking for MAB now. So L means which length you are supposed to take, not the length of BC, because MAB you are taking means the length of AB span is to be taken, that is to be 4. So next is 2 theta A. So theta A means what? Theta A is the slope at point A. So if you go for in the diagram, the slope A is which support? Fixed support. So in fixed support, slope will be equal to 0. In fixed support, the slope will be equal to 0. If you go for roller and hinge support, the theta will not be equal to 0. So here theta A value will be equal to 0. So if you go for this one, the theta A value will be equal to 0. So theta value will be equal to 0 means 2 into 0 equal to 0, and theta B will not be equal to 0. Why? Because that is a roller support. Okay, so theta B means what? Where it will come? So theta B, it will exist here. So here theta B exists. So it will not be equal to 0. So that is as it is, I have to going to write. So same thing, what you are getting here? Minus 20 plus 2ai by 4 into 0 plus theta B minus 0. This is the answer what you are getting. So it is written here, theta A is equal to 0 because it is fixed end, and delta, okay, next, minus 3 delta by L. What is delta? Delta means sinking up support. Delta means what? Sinking up support. So sinking up support means what? So if in the question it is not given, means that value will equal to 0. That value equal to 0. Same thing, what you done for MAB, same thing you can proceed for MBA. So what is the formula for MBA? MBA will be equal to MFBA plus 2EI by L into the bracket of 2 theta B plus theta A minus 3 delta by L. So same thing, MFBA it is calculated, that's plus 20 to EI by L. The span for AB will be equal to 4. So as per this one, 2 theta B. Theta B means what? Theta B means that is roller support. So roller support, theta B will not be equal to 0. So 2 theta B minus theta A. A means which support? Fixed support. So that value equal to 0. 0 minus 3 delta by L. So delta sinking is not given. So MBA. So MAB and MBA has been calculated. MAB is okay. MBA is okay. Next I will move for same thing you can proceed for the span BC. Same thing you can proceed for BC. So if you will see here for BC span, how it is UDL. Say UDL. So accordingly we can go for this one. Okay, so for span BC now. So span BC, what is the formula? So formula will be MBC plus 2EI by L into 2 theta B plus theta C minus 3 delta by L. So MFBC, what is the value fixed end moment for MFBC? It is minus 60 plus 2EI by L. So here in case of I have written 2I. Why it is written like that? Why it is written like that? So if you go in the question, here it is mentioned. Okay, for span AB, here it is I. Okay, it is in the diagram, it is not shown, it is like that. Okay, it is 2I. For span BC it is 2I. For span AAB it is I. That's means if moment of inertia of the section AB is I, and this is twice of I. Okay, so that's why that value has been substituted. For span BC, for span BC that is 2I. So 2E into 2I divided by 6. 6 means what? 6 means the span of BC was supposed to take into 2 theta B plus theta C minus 3 delta by L. So theta B means what? Which support? You check out. So theta B means what? Which support? Theta B means which support is there? It is roller support. So definitely slope is exist. Whatever theta C, it is fixed end. The theta value will be equal to 0. So same thing if you go for this one. So here theta C is equal to 0, theta B, 2 theta B plus 0 minus 3 delta by L. So sinking of support is not given, that's why that value equal to 0. That is written also here. So theta C is equal to 0, it is fixed 10, and delta is equal to 0 because no sinking of support. Okay. Next, same thing what you done for MFCB, same thing you can go for MFCB. So MFCB formula, what is the formula? MFCB plus 2 EI by L into 2 theta C plus theta B minus 3 delta by L. So MFCB it is calculated. Substitute the value 60 plus 2EI by L. So span BC it is 2I. Theta C means which support? Fixed support. That's what is 0. Theta B will not be equal to 0, and this value will equal to 0. So accordingly I substituted. So MFCB is also calculated. The step number 1 and step number 2 is what? Step number 1 is what? Step number 1 is you are supposed to calculate the fixed end moment. Step number 2 is what? What are the values that is to be calculated in this fixed end moment? We have to substitute in the slope equation. So after substituting in the slope equation, I got 4 equations. Okay, equation 1, equation 2. Equation 1 is for MAB, equation 2 is for MBA, and equation 3 is MCB, and equation 4 is MCB. Okay, so same thing. Now what I have to do in step number 3, we have to apply the joint equilibrium. Joint equilibrium means what? Okay, already it is told. Joint equilibrium means what? That is MBA plus MBA plus MBC, that is equal to 0. This is the equation you are supposed to use to calculate the unknown. So this is the equation I am using here. So MBA plus MBC is equal to 0. Just now I calculated the value of, I know the equation for MBA and MBC. So I substitute the value formula of MBA, where it is calculated, I will show you here. So this is MBA. So this is MBA. This value has to substitute. And next one what? MBC, na? So this is MBC. This is MBC. This value is supposed that should be equal to 0. So why? Because by joint equilibrium condition. So after substituting MBA and MBC, that is equal to 0. You solve this one. EI theta B plus 20 plus 4 by 3 EI theta B. So 20 minus 60 is what? 40. And EI theta B plus 4 by 3 EI theta B, that is 2.33 EI theta B. So if you solve this one, we'll get the value of EI theta B. So I got the value of EI theta B. So now if you got the value of EI theta B, substitute in all the equations. EI theta B is 17.143. So if you go for from equation number 1, so equation number 1 is what here? So here EI theta B is what? 17.33. If you substitute, we will get the value of MAB. Same thing. If in this second equation EI theta B is 17.33, if you substitute, plus 20 MBA value we can get it. Next, same thing, MBC. In MBC equation, this is the MBC equation. So here theta will be 70.33, substitute it, you will get MBC. Same thing, you substitute in the equation number 4, you will get the value of MAB, MBA and MBC. So this is the equation. If you will see here, MBA value, MAB, it is minus 11.42, MBA 37.43, MBC is minus 37.143, and same thing for CB also, that is 71.40. This is the way how we are supposed to calculate the moments for the beam. So this all the values has been calculated if you see here. Okay, finally, next. Okay, this is the case. Next, again in the question is asking you are supposed to draw the SFD and BMD. What is telling? You are supposed to draw SFD and BMD. So what we done? So for this beam, I separated out both the beams. So this for this beam, for first beam RA, and what is the moment developing at MAB, that is 11.428. It is negative sign, that's why I shown anti-clockwise, and here I am getting positive, that's what I have shown clockwise sign. So accordingly I have drawn the diagram for this one. Okay, as per my values, clockwise it is there, I have shown clockwise rotation. If it is anti-clockwise, that is negative sign. If it is negative sign, I have shown the anti-clockwise direction. So accordingly I have done for this one. The diagram has been done. Okay, so span AB 4 meter separated. Okay, so I am in order to draw the SFD and BMD. So what I have done for first part, for first beam, I have applied the condition of equilibrium. So what we done? I have taken moment about B is equal to 0. Okay, already you know this one. How we have to take the moment about B is equal to 0? Moment about B is equal to 0 means force RA into what is the span? 4 meter. RA into 4. How it is rotating? It is rotating clockwise. So that is positive I have taken. So you take 1 plus 1 minus. Okay. So RA into 4. Next, again 11.428. How it is rotating? It is anti-clockwise. So that's why it is negative sign. Okay, negative sign, because I am not multiplying distance. Why? Because it is already movement. I am taking the movement and it is already given the movement. So that's why no need to multiply the distance. Whenever there is a force is there, you are supposed to multiply the distance. So here it is 40. I need to multiply the distance. Yeah, this is the distance is 2 meter. So 40 into 2, how it is rotating? It is rotating anti-clockwise. So that's why negative sign. So if we equate this one equal to, if we solve this equation, you will get the value of RA. So what is the answer you are getting? 13.571. So same thing, I have applied total 3 condition of equilibrium are there. What are those one? Summation of fx equal to 0, summation of fy is equal to 0, and summation of m is equal to. These are 3 condition of equilibrium, sir. Summation of m is used. Now I will go for summation of fy. Now I am going for summation of fy. Summation of fy means algebraic sum of all the vertical forces. Means if the forces are going upward, I will take plus. If the forces are going downward, I will take negative. So if you see in this diagram, so RA is going upward, plus RB1 is going upward, that is plus, that is equated to 40 because it is going downward. Means upward force is equal to downward force. Okay, otherwise you can take this side minus 40. If you take that side afterwards, it will be plus. So if you will solve this one, you will get the RB1. Okay, same thing you can do for the second beam also. Second beam, how will do? Same thing, you can take the moment. You can take it B or you can take it C. So you will get the value of same thing here taken. Moment at B is taken. Moment at beam is how we are going to solve. So RC into 6. How it is rotating anti-clockwise. That is minus. Say next is minus 71.429. So plus 21.49. So, and next is 20. So for this one, how it will come? 20 into 6 into 6 by 2. And how it is rotating? It is clockwise. It will be plus. Next for this one, it is anti-clockwise. Okay, same thing, if you solve, you will get the value of RC value. Same thing, again you apply the condition of equilibrium for second beam. So what sum of vertical force is equal to 0. So RB2 plus RC is equal to downward force. Downward force for the previous case it is 40. Here it is UDL. So UDL point on 20 into 6. 20 into 6. If same thing, if you'll see 20 into 6 is done. So if you'll solve this one, RB2 value has been calculated. So all the values had been calculated here. So if you'll see here, now I have to draw the shear force and bending diagram. So just now RA value is how much? So how it is to be drawn? RA value मेरे को पता है. RA value is known. So RA is how much? That is 13.571. So this is the case. And next one is there is, okay, I'll go in the main diagram. We'll get an idea. So how the value it will come. So I will rough diagram I will show. Okay. So for this case, RA value has been calculated. So this is the diagram it will come. This is the case up to this D point. There is no load. Again minus 20 this is the case it will come. Okay, so if we'll see the diagram here, so this is the case what you are getting. So if you remember the diagram, so here how for this is the span, so RA is 13.571. okay, so there is no load between up to this point, up to point load. After that one minus 40, again it will come downward, and this is the case again it will go into increase. Again this, if it is UDL, that's why it will go like that, means inclined loading will be there. Again finally it will come to zero. This is the way how you are going to draw the shear force diagram. And next one is how we will draw the bending moment diagram, BMD. So first thing is you have to calculate the 11, 37 and 71. Okay, 40 and 90. So how the loading is there, I think I will draw here itself, you'll get an idea. So for this case, so this is the case now. So this is the case, and here this is the fixed. Okay, so here there is center point load is there, okay, and here it is UDL. Okay, so for this one, what is the free BMD? If center point load is there, free BMD will be equal to WL by 4. WL by 4 means what is the value of W? W is 40 into L is the span of the first beam divided by 4. Okay, so if you substitute that one, L is 4, so that is 40 kilonewton meter. So accordingly 40 kilonewton means this is the case what you are getting. So this is the case for free BMD. For second case, that is 20 into UDL na. So for UDL, what is the formula? WL square by 8. So WL square by 8 means what? 20 into 6 square divided by 8. So means that is 90. So this is free BMD. Actual BMD means what? What is the value we are calculated? MAB. MAB is how much? 11 point. So I will mark out this one here. So for MAB, the value is 11.4, and for the MBC, so second 37.143, and for MCB that is 71. So what I will do, I will join these things. Finally, this is the final bending moment diagram for the diagram for this problem. So this, if in this is the way how we are going to solve the problem. So first thing, only the thing is you required is you need practice. So you remember the steps. Step number one is what? First one is fixed end moment. This is the thing you have to remember. Step number two, what it is, you have to substitute, you have to use the slope deflection equation. Means what are the things you calculated in the equation number one? Substitute in slope deflection. What is step number three? In step number three, you have to apply the condition of joint equilibrium. So what is that is joint equilibrium you are supposed to use. Next, what is the equation? Step number 4. So after that one, you have to draw the you have to draw CFD and BMD. This is the way how we are going to solve the problem. Okay. So if you have any difficulty, please do a comment. So accordingly, I will tell you. Thank you. Thank you very, very much for your patience.